Unit 9, Section 4. Arcs, angles, chords, secants, and tangents. Lots of different words. Most of these you know. These are kind of reminders. A secant is a line that intersects a circle in exactly 2 points. This goes on in both directions for infinity. So a secant is basically the longer version of a chord. Here's your circle. A secant is going to be something like this, and it intersects at 2 points, and it goes on for infinity. A chord is going to intersect, but it's going to stop on the edges, and it joins the 2 points of the circle. So chord is the blue, and secant is the red. So let's see how we can use this. So we can use the theorems of chords, secants, arcs, angles, and tangents to solve problems, of course. So let's take a look at this rule here. If 2 secants or chords intersect in the interior of a circle, meaning that the intersection happens inside the circle, then the measure of the angle formed, angle 1, that's formed right here, is going to be 1/2 the sum. Sum means, correct, it means to add, of the measure of the intercepted arcs. So we're going to add the 2 arcs together, but then we divide it in half. So the arc PR, which is here, and arc SQS or SQ is here, we would add those together, divide by 2. All right? If a secant or chord and a tangent intersect at the point of tangency, that's there, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So the intercepted arc is going to be, so if you look at XTV, which is this angle here, it's going to be 1/2 of this arc. If you look at Y, or if you look at just TV, it's going to be, YTV, it's going to be half of this arc. So it depends on which arc it's intersecting, but it's going to be half of that. And then the last one is about tangents again, or secants. So 2 secants, 2 tangents, or secant and a tangent. Do you see how they're all outside the circle now? So when they're outside the circle, it's half the distance of the measures of the intercepted arcs. We already did this in the last section. We didn't really use it, but I introduced it to you. So I brought it back, and we will actually solve a few problems with it in this section. So that means that it's going to be half of the difference. We're going to have this one, the blue, minus the red, and then divided by 2. The blue minus the red, divide by 2. The major arc, the minor arc, major arc minus minor arc, divided by 2. Let's look at how this plays out in problems. Example 1, find the missing angle. Assume that lines that appear tangent are tangent. Okay, so this says if 2 secants or chords intersect in the interior of a circle, looks like they're intersecting, this is the angle we're looking for, it's half the sum of the measure of the intercepted arcs. So the sum is 110 plus 60, which is 170. We're going to divide that by 2. We're going to get 85 degrees. That was not complicated. It sounded like it, but it wasn't bad. All right, example 2 is about the secants and a tangent. So remember, it's going to be half the measure of its intercepted arc. So if we want to find this one, we're going to have to figure out what this arc is. We know what this arc is, but since we know that 360 is the whole circle, we can find that arc by subtracting 240. So now we know that that is 120, and we're going to divide that by 2, which will give us 60 degrees for that angle. Not bad. Do have to do a little bit of thinking, but not bad. All right, now we're at the secants or chords. This one here goes with this example. So the measure of an angle formed by 2 secants, 2 tangents, or a secant and a tangent. In this case, it's a secant and a tangent. This is this point of tangency, and this is a secant because it keeps going. From a point outside the circle, that measure is half the distance of the measures of the intercepted arcs. Okay, so half the distance of the measures of the intercepted arcs. So we've got, the difference, I'm saying distance. So we've got 174 minus 114, which is going to give us 60. And then we're dividing that by 2, which means that that angle out there is 30 degrees. All right, so now we have a solve for x. We go back to this kind of problem that we did in the last examples. And it says, once again, it's half the sum of the measure of the intercepted arcs. Okay, so they're being added together. So here's an intercepted arc and here's an intercepted arc. So we've got 10x plus 10 plus 5x. And it's going to mean that it's 8x, but it's going to be 8x times 2, right? Because it's actually supposed to be half. So we would actually, this is not times 2 because we know that the actual answer here is going to be divided by 2. So it's going to be here, it's going to be divided by 2 to start the equation. So we're adding these two arcs and then we're dividing them by 2 to get that answer because that's the rule. So since we don't want to do this, we're going to multiply by 2 to get rid of the 2. That's going to leave us with 10x plus 5 is 15x. We can add like terms. 15x plus 10 is 16x. Then I'm writing on this, but you'll be able to see it. I'm subtracting 15x. I'm going to get 10 equals x. And I'm done. X is 10. It doesn't ask you to find the angle, it asks you to find x. If you had to find the angle, it would be 80 degrees because you would just multiply the x by 8. All right, best of luck. Give it a shot.